Hello, my name is Michael, and thanks for watching this introductory video on Fig. In this video, we'll be giving you a bit of an overview of what Fig does, how it works, and we'll look at the problems that it's trying to solve. So Fig is an application for centralizing the management of settings, allowing settings for many applications to be managed in one place in a secure and intuitive way. It's written in .NET and designed to support .NET applications. And the application has been written with security at its core to sort of ensure sensitive values are protected, but also with the aim of simplifying the configuration process and reducing the possibility of configuration errors. It's got a stateless backend that allows it to be scaled and deployed in a redundant way to ensure its reliability. And it's packed full of features, and I'll demo a few of them later in this video. Finally, it's free and open source. And I've included a link to the repository in the description. So Fig is comprised of three main parts. There's a client NuGet package, and that needs to be included in any application that has settings that we manage by Fig. And that client is responsible for reading the definition of the settings to be passed to the API, requesting settings values to be applied, and heartbeating with the API to ensure the values remain up to date. The client talks to the API, which in turn relies on an SQL database, and SQLite and SQL Server are currently the two options supported. There's a Blazor WebAssembly application, web application, which provides a user interface for Fig and allows authenticated users to view and update settings and review the audit history to see connected clients and much more. And we'll be having a look at that later on in this video. Now, I think the best way to illustrate why centralized settings are important is to work through an example scenario. So imagine you're building a weather application, and the first service to be developed is a forecast API. So this service will be responsible for serving forecasts to our application. And as we develop the API, a need arises for some application settings to configure the service and allow it to operate in different environments and situations. So for .NET applications, the appsettings.json files are kind of the standard way of managing these types of settings. We add one of these to our service and populate it with a number of settings. So one of the requirements for this application is that it's resilient, and as a result, we decide to deploy multiple copies of our service behind a load balancer to ensure it's not impacted by hardware failure or schedule updates. But now we have three copies of the settings we need to manage and keep in sync. And then development progresses and we start to add other APIs into the mix, including a radar API and an account API. And these also require settings. And so now we're managing 9 settings files that we've got to keep in sync and up to date. And of course, you never want to make untested changes directly in production. So there's a need for different environments where changes can be tested and proven. And these number of environments may vary depending on the use case, but it's going to be at least 3, I would say, a production, a pre-production, and development. It's pretty unlikely in this specific scenario we're talking about now, but for some applications where installation occurs on-premise at the customer, these environments are then multiplied again per customer with perhaps additional environments for development and testing off the customer site. So as you start to appreciate, it doesn't take long before it becomes really inefficient to manage these setting files manually. And it's easy to make mistakes which result in some services functioning incorrectly or not at all. There are tools out there today which solve this problem by adding the settings to the deployment pipeline. And this is particularly true if your application is being deployed in containers. However, these approaches are not perfect depending on your scenario and still have other problems which we'll have a look at in the next section. Okay, now let's move to looking at the settings themselves. So continuing our scenario from before, here's an appsettings.json file which might be for our forecast API. In my experience, the person or team responsible for doing the deployment of the application is really the same person or team who were the ones who developed it. And so the development team may not even have access to the source code, and so they'll be relying on documentation to perform the configuration. Documentation can, of course, be missing or incomplete or out of date, and this can potentially result in configuration problems or just wasted time. So in this case, we'll assume that the documentation is missing, and then we have to read the file as is and look through the settings and let's see if we can have any questions or spot any potential problems with the settings as they are at the moment. So starting with the first one, temperature units, and we can see that's set to Celsius. So this presumably maps to an enum behind the scenes in the application. But in this settings file, it's essentially a magic string. We don't know what the other possible values are. Presumably it's Fahrenheit in this case, but maybe also Kelvin. And so we can't really change this value with confidence without having a look at the code or consulting documentation. And we also don't really know what the implications of a change here might be. So does it change every output from the API, or is it change the way we process the information, process the incoming data? We just don't know. Looking at the next set of credentials, we've got about 5 settings here which relate to open weather, and this must be the service we're using to get our source weather information. The URI looks fairly straightforward. We've got this Boolean value here, use credentials for open weather. And the immediate question I have around that is, if we set this to false, do we still need to specify the username and password or the API key? What is in scope here and what's affected, and what's the impact of changing this setting from true to false? Another obvious problem here is that the password and the API key, which are both sensitive values, they're sitting here in plain text. And that's obviously a security risk, regardless of where this application is being deployed. We could encrypt these values, but then our application would need to know how to decrypt them, and that adds complexity to our deployment. And also we need to code that to make that happen. The other question I have around this is how do we validate that this information is correct? I mean, it may be correct in a standalone sense, but there may be a firewall in our environment where we're deploying, which means that this URI is not accessible, or the password or API key may have expired since we got them. And so there's not really an easy way of validating this unless we just run our application and then hunt through the logs of the application to see if things were successful. And even then, we don't know if the application's logging at a sufficient level to be able to identify that. Forecast days, currently set to 5. It's a bit difficult to know what the valid values are for this setting. Can we set it to 10 or 20, or is there a maximum value that we can set it to? We don't know with the information we've got in front of us. Log level is another one of these that is magic string and probably hooks up to an enum behind the scenes, but we don't know for sure what the other valid values are for log level without consulting some documentation. It's not clear what debug mode does if we set that to true. How does that change the application, and are there any risks in setting this? Probably this timeout value is set to a reasonable value and we don't need to change it, but we don't know that for sure, and we don't know what the implications are of changing this value to a much larger or much smaller value. Our database connection string looks fairly standard, but I guess once again we don't know how to validate that this value is correct. Is that server accessible within the environment, or is it not? And is integrated security valid? Is the user that this service is running as have access to the database as that's been set up? And then we've got this allowed cities list here at the bottom. And this presumably is these sort of city codes are coming from open weather, and perhaps map up to London or Paris or Berlin. But we don't know that for sure. And so there's time and effort there to go and have a look at open weather's documentation and try and work out for ourselves what are the valid options and what the implications are for adding or removing items to this allowed cities array. So this is quite a small list of settings, but even from this list, there was quite a lot of ambiguity and questions about the best way to configure the API. So let's take a look at how these same settings would be configured in Fig, and we can have a look through the differences. Okay, moving over in here, we get presented with user interface. Before I dive into the settings in detail, I'll just quickly have a look at the user interface and the options that are available. So along the top, we've got a set of links to different pages within the application, and they show different aspects of information and configuration, and we'll go through those a bit later on. On this main settings page, we have a list down the left-hand side here with the different setting clients or applications that are having their settings managed by Fig. And there's a search box here to filter those down and also filter across the settings. If we select one of these, the settings are presented in the middle, and we can also see a set of buttons along the top to set different settings or perform different actions around that setting client. There's a little 1 here in the list, and we can see that indicates that there's one online client. So there's one forecast API application currently connected to Fig and actively monitoring for settings changes. Okay, so diving into the settings then. The first one we've got here is the temperature unit setting. And so one of the concerns that we had around this one in the appsettings.json file was that it was a bit of a magic string. And this problem's gone now with Fig because we can select from a drop-down the value that a list of all the valid values listed in the drop-down, and we can select one. And when we do select it, we can see that we get a notification saying that this setting has been modified, and the save and save all buttons pop up to allow us to save this change if we want. In addition, we weren't really sure what the impact of changing this setting would be. And now we have a description here that's saying the selected units will be used for all temperature responses from the API. So that ambiguity has also been removed. We can see here there's a little lightning bolt next to the setting, and this indicates that the application will read this setting and apply it in real time. So Fig has the ability or will push out all settings changes immediately or on the next poll cycle out to all the settings clients, but not all applications are written in a way that they can take advantage of those changes. And some settings are only read on startup. So for example, you might have a database connection where you set up the connection on startup and don't recreate it. And so changing that connection string at a later point won't have any impact. But this one indicates in Fig that it will have an impact. So the person configuring knows that this change will be applied immediately. We can hit save on this one, and we're prompted for a change message. Temp, and this save message is then logged along with everything else in Fig so we can understand why the setting was changed when it was changed. Okay, so moving down to the next setting here, we've got our group of 5 settings which relate to open weather and the connection there. And you'll notice that these settings are read-only in this client. And that is because the setting is managed by Open Weather API. So we click on that, and this is actually a setting group rather than a setting client. And Fig will group settings together when they're common between multiple clients. So we can see here that this setting sets the value for the forecast API, but also the radar API. And we can change it here in one place, and then it gets applied to all those clients that need that information. And this cuts down on rework and means that all of your clients are kept in sync. If, for example, our password needs changing, we can change it in one place and it's applied to all clients at one moment. We can separate out a client if we don't want it to be grouped at some later point using the instance button as well. So the URI is there, not much to talk about there. Moving down to the use credentials for open weather. If I toggle this one off, the username and password disappear. And so that is a clear indication to me that those two settings are not required if this setting is set to false. Can set it back to true. We've got our username and our password, and both the password and the API key are set. As we can see that there's some value under there, but the value is not pushed down to the web client, and so not available at this point, but we are able to update it. So if we wanted to hit the update button and put in a new value, so let's say we put in a password, and Fig will give us a rating on the quality of that password and how long it will take to crack. It won't prevent us from putting in a terrible password, but it will, I guess, advise us that there's that the password choosing is not ideal. And we need to enter it twice as standard to make sure before we can apply it. And in this way, we don't need to worry about encryption because Fig takes care of that for us. All the values are encrypted in the database, and when they're pushed back to the client, provided the client has a valid client secret for it, then it will get those passwords back in plain text and be able to use them immediately. Okay, moving back to our API, we can go down to forecast days. Now for this one, we weren't sure what values were valid, but the description here tells us now the values between 1 and 7 inclusive are valid. But maybe I didn't read that, and so I can change it here. I can also change it manually. But if I change it to a value outside the value range, the valid range, I get a message here that values between 1 and 7 are allowed and not 8. So Fig won't actually prevent you from saving a value of 8 here, but because it might be that the validation that's been applied to this setting was incorrect or didn't take into account some sort of situation. So we don't want to block that from happening, but it's an additional indication to the person configuring that this value is probably not going to work with this client. And our database connection string is also read-only, and that's managed in the database connection. And in this case, the account API and the forecast API are the two setting clients used for that one. If we make a change to this one, so let's say that we say integrated security false, we can see this is marked as being modified, and we can see that the account API and the forecast API now have pending changes. Even though we changed it in the group, it's the two setting clients actually that are getting those changes, and we can see those changes reflected. If we scroll down to this one, that's reflected in this client. Yep, so that's the database connection. Now let's just change that one back. We can use this one, this button here, to undo any unsafe changes, and we go back to a clean state. And the next one was the allowed cities. So we remember previously that we had these short codes, lon, par, and bur, which we weren't sure exactly what they stood for. Now I've got a clear indication that lon stands for London, par stands for Paris, and bur stands for Berlin. And if I want to add a new one, I'm choosing from a drop-down rather than typing in a string. So how is this possible? We don't want to build the knowledge of what the settings are into our integration because they're owned by Open Weather and therefore are not something that we want to bake into our application. So what we can do instead is we can use a feature in Fig called Lookup Tables. So here there's an API for this as well, but we can also do it manually where we put in the keys and the values up front, and then we get a drop down in our settings. If I was to remove this, then we would just be entering strings as before. And this means that it gives some extra context to the person configuring the settings about what these values are. And this might be like a database ID mapping to something if we've got different database configurations, or it could be anything else. Anything where the actual, we're using some sort of key and the value is not really owned by our application, but some external party. It can be useful here. And the client will, of course, get the Lon, Par, and Burr values. It won't get this London, Paris, Berlin information. That's only for the person doing the configuration. Okay, so what you might have noticed there is that we had a few extra settings in our JSON file that we haven't seen yet in this page. And these are these 3 advanced settings here. So we can toggle advanced on. And if we scroll down, we can see log level, debug mode, and API call timeout milliseconds. And the idea here is that these settings are ones that are probably not going to need to be changed for most configuration scenarios. For example, the timeout value is probably set to something that's reasonable and will work in most use cases. And therefore, it's not something that a person doing the initial configuration is probably going to be concerned about. It might come into play if we start getting timeouts or the application is not responsive and we want to start tweaking things, then we can go in. But the default value is reasonable and probably won't need to be changed. And as a result, we hide it from the configuration so that there's less values to configure, and that we don't get cluttered with a lot of settings to configure in one go. We can focus on the ones that do need to be changed and set, and not others. So that's the advanced settings. A couple of other things we want to talk about here. So we talked about the database connection string, and we've got a database connection string, but how do we validate or verify that that database connection string actually works? We can do that with a verifier. So a verifier is a small piece of code that will run, and it will take the database connection string that we've set in and test it against the database. So if we can run this verification and we get back a message saying that this one passed and it was making a connection to the database using this connection string. Now, it's actually the Fig API that's making this database connection rather than your application, but they're probably deployed in the same environment, and therefore it's a fairly representative test to make sure that there's no firewalls or that the connection works as expected. And the same thing again for open weather connection. We can run this verification and we connect, we check the different settings and we get back a result. If I, for example, made a change to this open weather URI, so let's remove this last piece here and we can save. We don't need to enter that. And then we go back to our forecast API and we run this verification again. Now our URL is not correct and our verify fails, and we get a bit of information about why it failed. So this is just an extra tool that's available to people configuring to validate that the settings are right. Now, there's a couple of other buttons we want to talk about here. One is this one here, which is reset to default value. So imagine we've made a bunch of changes, we've saved them over time, and then we want to revert back to what it was defined by the application. We can use this button here to do that, and it will set it back to the initial value for the setting. We can also click this one here, and this one will toggle the history of the changes for that value. So we can see here that the admin has made changes. They've changed it from 5 to 4 to 6 over time, and the initial registration was 5. So it's actually already at the default value. And this allows us to see if there has been changes. If things stop working, we can jump in here and see if those why. So in addition to managing settings, Fig also has a few other tricks up its sleeve. If we go over to the events page, everything that happens within Fig is logged. And we can see those logs in the event page, including setting changes, updates, when clients connect, disconnect, when people log in and out of the web app, etc. And we can filter these events by date time, and we can also use the filter buttons here on each heading or each column to filter even further down to get the events you're after. I'm logged in as an administrator at the moment, so I also have the ability to manage user accounts, including setting the roles of users. On the Collected Clients tab, we have a list of all of the clients, so all of the applications where Fig is managing their settings listed, and some handy information around those clients. For example, if they're running the latest version of the settings, their uptime, last seen, last setting change, the IP address and host name, the version of Fig, and also the application version, host name where they're running, current memory usage, if they have any configuration errors that they've listed, and if Fig's detected any memory leak issues with that client. We also have the ability to restart the client if they have implemented that. There's an event from the client, and if you've hooked onto that event, we can push the restart button and request a restart for that client. Just to give you a demo of how this might work. So if we've got the account, let's say the forecast API, that one's currently set to true. If we go back over to the settings, and in the forecast API, we change this from Celsius to Fahrenheit, and we save, and then we go back to the connected clients, we can see this is now false. And this is because the forecast API has not yet received those settings updates. So it's not yet running the latest version. By default, clients heartbeat every 30 seconds, but that's a configurable value. So it'll take up to 30 seconds for this value to propagate. If we hit the refresh button now, we can see this has gone back to true, and the forecast API is running the latest version. There may be times when you are running multiple API backends, if we're running this in a redundant way. And this page shows us the API instances that are running, including their version, how much memory they're using, IP address, how many requests they're receiving, and also the plugin verifications that are registered with that API. And the idea is that you should have the same registered with all APIs so that it doesn't matter which one you end up with, you'll get a consistent response. Fig has the ability to import and export. There are 3 different types of exports. We've got a full export that imports all the metadata in addition to the settings values, and those ones can then be imported and used directly within Fig. We have a value-only export and a value-only import then, and those ones are just the values that Fig's going to use. And for those, Fig needs to wait for a client to register to add the additional metadata before they can be used, and they'll sit in this deferred import clients area until that happens. And then the third type is a setting report type, where we can export the settings in a markdown format, which can be useful for reporting or auditing, that sort of thing. In addition to importing through the web client, we can also import from a file location automatically on startup or using a file watch. There's a number of configuration settings that allow us to tweak different aspects of Fig's operation, including allowing or disallowing certain features of the application and tweaking how it does memory leak analysis. Fig has a fully featured webhook service, so we can send webhooks out when certain events occur inside Fig. There is, I think, 7 events supported, including status change for clients, so connected, disconnected, when a setting value gets changed, when Fig has a suspected memory leak for one of the registered clients, when a new client registers or registers an update. So if there's new settings that have been defined since the previous registration and the client re-registers, then Fig will take those new definitions and keep the old values and reapply the old values onto the new definitions. We can ask Fig to monitor for a minimum number of running sessions. So we can say, I expect there to be 3 copies of my forecast API running at any one time. And if it drops below that, Fig can send a message for the webhook. And also if a client reports a configuration error. The use case for the webhooks is probably some sort of Slack or Teams client where you can report in or get notified of certain problems that might be occurring within Fig or within your solution. We have lookup tables, which you've touched on before, that allow us to look up information that might not be owned by the client, but the client is using to operate. And then we have an insights page, which is a bit of a work in progress at the moment, but it shows memory usage over time and suspected memory leaks at the moment. Okay, so you might be wondering just how much effort's involved to take advantage of all the features that Fig offers. And the good news is that it's actually quite easy to integrate your new or existing service into Fig. I'll create a separate video, I think, explaining this in more detail and give you a detailed view and step through the process exactly. But to give you a rough idea, let's have a quick look at the code for the forecast API and see what steps were required to get it up and running. So here I have the forecast API, and it's just a standard .NET template project that I've created. And all I've done is I've added the fig.client NuGet package. Then in the program.cs file, I've added this line of code here. So basically, there's an extension method on the services, which allows us to add Fig. And when we add Fig, we call out our settings class, and this can be called anything, but in this case, it's called settings, and we've added an interface on it so it can be used or dependency injected into where it's needed. There are a few options. So we've got a API URL or URI, and this calls out the location where Fig is, the Fig APIs is residing. And then the client secret, which should be unique for each client. Now I've hard coded both of these into the code here just for simplicity, but in reality these should be configurable values, and Fig can read these from a number of different locations, such as your appsettings.json file, or from an environment variable, or in the case of client secret, there's some other options which might be more appropriate to secure those values. There are a number of other options available there, and I won't go through those in this video though. We just need those two to get up and running. And if we have a look then at our settings file, so you probably already have something like this file anyway to map up to your appsettings.json. And so all we've done here is we've added the setting attribute, and the setting attribute takes a description parameter as well as a default value. And it also takes a third parameter, which is the supports live update, which is defaults to true if you don't specify it. And we've just done that for all of our settings, and we've also extended a settings base class here. and defined a client name, which is what Fig will use as the name for this client. This must be unique across your whole solution. You can't have two, unless they're the same application, you can't have two clients named the same thing. And then we start adding capabilities. So we can define the display order, so we can define how the settings are going to be ordered when they're displayed to the person configuring in Fig. We can call out a group name, and then settings with the same group will be grouped together in this group. We can specify valid values. So in this case, we've said go off to this enum, temperature units, and get all the values in there. But we can also specify them manually as well if we want to do that. We've also got this enable settings. So this is where we could turn on and off settings or make them appear or disappear depending on the value of this property here. We've got a secret attribute, which makes this one secret and so not displayed in the user interface. We've got a validation attribute, which allows us to specify a regular expression and an explanation of what that regular expression is validating. And we also have an advanced attribute here. I think there are a couple others. There's a lookup table one down here as well. You can see there are a couple of other ones that we can use, and you can find all these documented on figsettings.com. In addition, we've got a couple of class attributes, and these are the verifications. And so we call out a verification. In this case, there's two types of verification. There's a plug-in one and a dynamic one. These are both plug-in ones, so we just call them out by key, and these need to have been pre-registered with the API. And then all we need to do is to start using it. So if we go across to our controller, we've got our I settings, which is dependency injected in, and then we just start using those settings for whatever we need. And the live value or the most up-to-date value will always be available if you read directly from the settings. And that's basically it. So it's quite straightforward actually to add Fig to your existing applications or to integrate into a new application. It's really only a few steps required, and you should be up and running fairly quickly. So I plan on creating some other videos on other aspects of Fig as well, such as security and webhooking integrations. So if that's of interest to you, please keep an eye out for those. And that's all I had for this video. So thanks for watching, and see you in the next one.